We have looked at how to initialize a list view and a grid view with a default array adapter, but in many cases, we will need to customize our adapters to the application requirements. The adapter component is highly and easily customizable for a multitude of different design parameters. The interface Android Widget Adapter, or more particularly Android Widget List Adapter, will need to be implemented in our adapters in order to offer the capability to utilize that adapter in a grid view or list view. In order to implement our own custom adapters, there may be a need to override some of the methods for the adapter class. Some of these methods may include getCount, which will inform the dynamic view, whether it be a list view or grid view, how many items it will need to display. Realize that this can change in runtime, and in the case of change, the view associated with this adapter will need to be notified of a dataset change or reset. getItem, which receives an integer for the position of the item requested. This method returns an object that can be any desired object you designed to represent an item in the list or grid view. getItemID, which receives an integer for the position of the item ID requested. This method returns a long for the row ID for the associated item at that position. getView, which receives an integer for the position of the item, a view, and a view group. We'll cover more about this method shortly, but it returns a view to represent the requested item in the list view group. It is also important to notice the register dataset observer method, which can be called on an adapter. This method is in place to allow other elements to listen for changes in the dataset of an adapter and act accordingly. The getView method in an adapter allows the adapter to return the view that should be displayed for any item. This view will then be used by the list view or grid view for displaying the item in the requested position. The view can be inflated from an XML resource by using the Layout Inflator class. This works in a similar fashion as when a layout is inflated in activity by the call to setContentView. What is returned is a view instance that can be manipulated and configured for desired UI parameters. The view returned from the getView callback can also be generated by using simple creation of an instance of a view object or reusing a view object. It is important to note that the convert view given as a parameter in the getView method may often be null and must be verified as non-null before using. Once the view is initialized, it can be customized with the appropriate details for the item at the given position. Since this is all done dynamically, different views and different XML assets can be used based on the position parameter or other parameters. For instance, it is easy to implement that even rows in a list will be based upon a completely different XML asset than odd rows in the same list. Since these views are being created in our adapter, they can be easily retained and updated when needed. For instance, in the case of images, we can display a temporary placeholder image in the list until an actual image is downloaded and then updated for that view in that item. Please note that in many cases, the list view and grid view holding the items will need to be notified when it needs to refresh that item or multiple items. This type of design paradigm offers many advantages when developing your applications by naturally separating the code and logic for the items in our list and the list view itself, meaning that the list view can be resized or migrated to another screen completely, while the UI and logic for the list items can be separately worked on. This type of modularity can offer major advantages when it comes to defining and dividing development tasks. Now let's take a look at a custom adapter in code in Android Studio. In order to implement our own custom adapter, we have created a project with the same starting parameters as our previous list activity. In the main XML layout for our main activity, we have a list view with the ID LV counting. Now if we jump into our Java code, we see that we grab our list view after loading our XML layout for this activity, and we set an adapter of class CountingListAdapter, which we'll get to in a moment. And then finally we set another onItem click listener that displays a toast with a string returned from getItem, as we previously did in the list view code example. Now let's look at our custom adapter class. We have our custom adapter extend the base adapter class. It also has a constructor which receives a layout inflator, which we grab from our activity easily by calling the getLayoutInflator method. We'll be using the layout inflator shortly. In our getCount method, we return a constant count, which we set here at maxCountConstant of equal to 26. In the getItem callback, which will eventually be used for the toast, when the item is clicked, we return two different computed values based on the position of the item. If the item's position is greater than the max count divided by 2, then we will return the string position and down the list. Otherwise, we will return the string this is item plus the position. Now let's take a look at our getView method. In our getView method, we first check if the converted view is null. If so, then we need to inflate an XML file. In this case, the XML file list items is inflated to converted view. Let's take a look at the list item layout now. In the list item layout, we have a horizontal linear layout that contains an image view and a text view. Now let's go back and see how these two components are used. We grab the image view and text view from our converted view, which may have just been inflated. Notice that in order to use the findViewById method that we are familiar with from our activities, we need to call it on the converted view, so that it knows which view to search for those IDs. Once we have the image view, we set it to a system resource based on if the position requested is an even position or not. The text we set to the string value of the position that was given in this method, and we return the converted view. Now let's run the application and see the results that we are given from this code. We see that we are presented with a list of items from 0 to 35. As expected, the images alternate, with an image that is set for even numbered positions and a different image set for the odd numbered positions. That is then followed by the text for that position. When we click on an item below the max count divided by 2 threshold, we see that it displays the text from the getID method return based on the if condition being false. And if we click a position that satisfies the if query, we see that it displays the text from the if condition. Thank you for joining us in this lesson on custom adapters in Android. Join us in our next video where we will cover the lab exercise for the previous lessons.